Hi there. We have entitled our talk, CSCL Gets to Work, Towards Collaborative Learning in the Workplace, because as this symposium focuses on team formation as a way of setting up for good collaborative learning, our goal is to develop a paradigm that ultimately we can inject into the workplace. Now, you'll notice that the studies we'll talk about have all taken place in project courses in a formal learning setting. And the reason why we're doing our research in this context with the long-term goal of injecting into industry is because we see actually a similar challenge. In industry, the focus is on productivity, but we want to inject the opportunity for people to learn because there's a problem now with people being able to keep up with the rapid pace at which the landscape of work is changing. Similarly, in project courses, actually, though the goal is about learning, students default to a stance that's almost like industry, where what they really want to do is produce some good project and get a good grade, and that undercuts the learning that these project courses are meant to offer them. So, what we believe that's connected with this symposium is that one way of setting up teams so that they can do their work but nevertheless learn is by using an effective team formation strategy that predisposes the teams to learn well together. So we're going to introduce a paradigm like that, but we're going to also challenge it across many different contexts. But we're also going to introduce a new kind of explicit scaffolding for group processes in the later discussion in this talk. And just as a teaser, that's referred to as mob programming. And here it actually comes from industry and refers to a rotating set of roles that are meant to scaffold the work. But we'll talk about that more later. So the construct that underlies all of the work that we're going to talk about is called transactivity. And we're going to talk about both its social and its cognitive underpinnings. Then we're going to talk about how it can be the basis for a team formation strategy, which has been validated in a lab study and in a massive open online course. But then we're going to apply it to software teams. And in doing so, we're going to challenge the generality of the approach in two different ways. In one study, the challenge is that though in the prior validation studies, teams were assigned and students didn't have a choice, in this project course, the team assignments that were provided were framed as suggestions. And now we can evaluate, will the algorithm nevertheless continue to have a positive effect in this context? In the second, the challenge is that the groups are heavily scaffolded in terms of their processes. And then the question is, do we even need the effective team formation strategy in that context? So what's actually a stronger influence on behavior, the explicit scaffolding of processes or the implicit scaffolding provided by the team assignment? And so we'll talk about that in our second study. And then we'll provide some conclusions. So transactivity, this is the important construct that is going to be a running theme throughout this talk. Transactivity, very simply put, is the property that an utterance expresses reasoning, and it expresses it in a way that builds on the reasoning expressed in another utterance, often by another student. So here's an example, and this was from an environmental sciences unit. One student is proposing a power plan that involves the use of coal, and another student is responding transactively, referring back to the reasoning of the first student, but extending it and challenging it in two different ways. So it meets our requirement. It refers to the reasoning in a previous utterance, and it builds on it using original reasoning of the student who articulated the second utterance. And that makes the second utterance count as transactive. So we didn't invent this construct of transactivity. In fact, constructs like transactivity show up in virtually every theory of learning, but the construct of transactivity specifically was framed within a Piagetian learning paradigm where it's connected in a way to the construct of cognitive conflict. Now, cognitive conflict you can't see. That happens in someone's head when they experience that there's a gap in their understanding. transactivity has sometimes been referred to as sociocognitive conflict. It is a kind of conversational event that can act as a trigger for cognitive conflict. Now, you don't have to adopt a Piagetian stance on learning in order to value transactivity as a construct. So the same construct, though it might be referred to under a different name, could be seen as valuable within a Vygotskian learning paradigm, as this utterance might serve as scaffolding for another student's articulation of reasoning. And that can be justifiable as a valuable conversational event within that kind of a framework. Now, in prior studies of transactivity and collaborative learning, it has been found that teams that are high in transactivity have been associated with higher learning, higher knowledge transfer, better knowledge integration, and more effective problem solving than teams that are lower in transactivity. In our own prior work, and specifically the work by Ka-Jin Kwan, who's still a member of this community, the idea of the relationship between transactivity as a construct, so the concentration of transactive utterances found in collaborative discussions, they correlate with other indicators of social relatedness. So in this particular study, the investigation was speech-style accommodation. Speech-style accommodation is associated in the sociolinguistic literature with mutual respect and common ground building. And so in a Piagetian framework of learning, the idea is that when pairs of students are working together, if they have this kind of mutual respect, in his framework, he framed it as a power balance, then students are more predisposed to experience in that encounter a cognitive conflict. And so then you would expect, if you see the preconditions for this kind of encounter, that you will also see these transactive utterances. And in fact, that's exactly what she found. Now, since there seems to be a tight connection between the occurrence of transactivity and its social underpinnings, you could see the expression of transactivity as potentially indexing these social conditions. And therefore, you might use the observation of transactive exchange as a signal for collaboration potential between the individuals interacting together transactively, and therefore it might form the basis for a team formation paradigm. And in fact, in Miao Miao Wen's dissertation work, this is exactly what she did. In an online course, students first worked individually, then they posted their individual work. They were asked to give each other feedback. The feedback discussions were analyzed automatically for transactivity. Then transactive exchanges between pairs were used to estimate a collaboration potential for each pair, and then a constraint satisfaction algorithm used that estimated collaboration potential as the basis for assigning students to teams in such a way that students were most likely to end up in teams with other students that brought out the best behavior in them. So first, this was validated in a lab study, and then it was tested for generality in a massive open online course, and the effects were positive, both on interactions between students once they were in their teams, and also in the level of knowledge integration found in the work that they produced. So now we're going to look at how this extends to software teams, and in particular in a project course environment. And these, I'm going to talk about two different studies in the same course. And this is a course, a 16-week full semester course on cloud computing, where students are doing software development together. It's an online course that spans 3 different CMU campuses. But what's different here is that students are given recommendations for what team they should be in, and we use the same algorithm. But here, students actually could choose not to take up the recommendation. So the question here is the algorithm enough, or are there contextual factors that might actually make it not end up having a good effect? And you could think of it as analogous to the medical context, where the doctor gives you the best medical advice, but you may not take it up. In this particular course, 3-person teams were constructed out of a whole class. And so team assignments were computed and given to students, and then they had their choice how they were going to respond. And actually, very few teams ended up taking the recommendation. And so therefore, the whole thing really broke down. What students had a strong tendency to do was to fall back on choosing their friends to work with, which actually turned out to be a very poor strategy for picking a team. So let's actually drill down and look at that in a little bit more detail. So one thing is that regardless of whether in following the paradigm that when students were given the recommendation, they took it up or not, once they ended up in a team, you could, in a post hoc analysis, compute what was the criterion score for the team they ended up in comparison to the team that they were assigned to. Because nevertheless, the entire course, each pair of students had an estimated collaboration potential. The first thing we checked was whether that estimated collaboration potential, whether there was some evidence that it actually made a prediction about how well students would perform in teams. And actually, in terms of the auto-graded portion of the software produced by the students, we did see a positive effect that was consistent with what we would expect from the prior validation studies. However, students, when they assigned themselves to teams, we checked to see would they actually, in their own self-selection, choose teams that were, just as good on our criterion score. But in fact, they, on average, chose to assign themselves to teams that had a significantly lower criterion score than the ones that they were assigned to via the algorithm. So as mentioned, most students fell back to choosing their friends as teammates, and actually this had many negative effects. So we did a post-course survey, and we looked at how students evaluated their teams and also how they chose to assign themselves to teams. And so we saw student teams that were based on friendship, ones that were based on observation of how smart students were or what kind of working skills they demonstrated in the online course environment. And then there were the teams that actually took the recommendation. And those that assigned themselves to teams with their friends did the most poorly on the project. They also reported lots of problems with division of labor and relationship issues. So the transactivity formed teams performed best. However, the teams that were formed based on observation of how smart students were or what their good work ethic was were not significantly lower. Okay, but the important take-home message here is the gap between theoretically optimal and practical. The algorithm itself has been validated in prior studies, but in this particular context, uptake was low. And the history of the course, which had been offered 10 times before, where students in the past had been able to select their own teams, and in fact, usually based on their friends, this culture that came into the expectations in the course kind of undermined the positive effect that the algorithm might have otherwise had. So we also did a follow-up study where we gave the results from this study to see if we could convince students to take the recommendations based on the result that working with your friends was found to be a poor choice, but they still wanted to work with their friends. Okay, so let's move on to the second environment. Here we offered really strong support for structuring teams. And we contrasted transactivity-based team assignment and random team assignment in this study. But regardless of whether students were in the randomly assigned teams or the transactivity assigned teams, they nevertheless had this explicit group process structuring in this paradigm called mod programming, which I'm going to talk about in greater detail. I just want to point out that this idea of contrasting the effect of implicit support, where team formation can be seen as that, and structuring of group processes has already been investigated previously in Xu Wang's cscl paper of 2017. However, in that study, the scaffolding of group processes was a weaker manipulation, and also in this study, we don't have, well, anyway, let's leave it at that. Okay, so let's talk about the scaffolding. It's called mob programming. There are 4 roles. There's a driver who's doing the software development, a navigator who's actually directing the process. There's a mob role where the person or people in the mob role can play a supporting role. They can offer challenges, they can look up things, they can try out other solutions and weigh in on the decision making. And then there's a facilitator who could be like a learning facilitator, drawing out more reflective discussion from the others. And this role in our study is taken up by a conversational agent. And the roles rotate, so everyone in the group has the opportunity to see the problem-solving process from a different perspective in each role. So this gives a clear division of responsibilities. It prevents cognitive overload because it's never on only one person's shoulders to push the process forward. It gives people the opportunity to learn from one another, and students can't choose to default to roles where they're already good at that particular part of the process because the roles rotate. So we did a 3x3 Latin squared design, that 3 different tasks and 3 different conditions, where the 3 conditions were transactivity form teams, random teams, or individuals. But in all of the group contexts, we used this mob programming scaffolding. And the finding was that the scaffolding, the extent to which students cooperated with it, predicted the extent to which students engaged in reflection about the underlying concepts behind the software development, and that can be seen as a positive influence on the kind of learning orientation of the group. But what we didn't see was that the transactivity form teams were more likely to do this than the random form teams. So what we see here is that when all of the teams had this really strong scaffolding for their processes, we don't see a further positive effect of the kind of weaker manipulation of the team assignment. So in conclusion, transactivity was found in prior work as an effective basis for team formation. But the message here is that AI is not enough. The recommendations are good. They set up a team to perform and learn well together. However, this manipulation is relatively weak, and so it may not be necessary if another stronger form of support is offered. And also, it may not be taken up, or it may not be experienced if the teams actually don't have to take the recommendations.